The Earth is covered in tectonic plates that slowly move around its surface. Most of the time, we don't feel a thing. The places where they meet are called fault lines, and that's where most earthquakes happen. The edges of the faults are rough and sometimes get stuck together. There is then a build-up of energy as the plates continue trying to move, or come under pressure from other plates. When it becomes too great, the plates suddenly slip, releasing energy in seismic waves that shake the Earth as they move through it. Earthquakes are recorded by sensitive instruments and measured on the Richter scale. It's an exponential scale, which means every number up is a tenfold increase in the size of the earthquake. Earthquakes that measure up to about 4, or with epicenters far below the Earth's surface, are barely felt. At 6, some buildings are generally damaged, depending on the quality of construction and how deep below the earthquake's origin occurs. Quakes close to the surface produce more damaging energy waves. But even earthquakes this size can be devastating. The one that struck Christchurch in New Zealand measured 6.3, but killed nearly 200 people. In the 7s, buildings can separate from their foundations. Underground pipes may be broken, and there will be visible cracks in the earth. A magnitude 7 earthquake caused the deaths of about 220,000 people when it struck Haiti in 2010. An earthquake measuring 9 or more on the Richter scale will leave almost total devastation, and the energy waves will be visible as they move through the Earth. The earthquake behind the Boxing Day tsunami measured 9.1, and it was a magnitude 9 that devastated part of Japan in 2011. In 2004, the world reeled when a massive earthquake near Indonesia triggered the devastating Boxing Day tsunami. Hundreds of thousands of people died and huge areas of land were destroyed. But where do these monsters of Mother Nature come from? Undersea earthquakes can sometimes cause no damage at all, with tectonic plates moving side by side and nothing but water to feel it. But when plates shift under each other or create a gap, the Earth's sudden movement can displace huge amounts of water. Imagine the ripples caused by a rock landing in a pool. A subduction earthquake under the ocean is the same thing, but upside down. The displaced water is pushed out with great force, forming tsunami waves that travel about the same speed as a plane. Tsunamis can hit land with extraordinary force. Some measure up to 30 metres high. Nations across the Pacific are particularly vulnerable to both earthquakes and tsunamis. Since 2004, early detection systems have been established across the Pacific to measure earthquakes and warn when a tsunami is generated. But the warning can come barely hours before the wave hits. The long-term impact of a massive tsunami can be harder to escape, potentially fatal waterborne illnesses and sometimes loss of homes and loved ones. In the wake of a devastating tsunami, every moment counts when getting help, food and water to the area. Hurricane, typhoon, cyclone. 3 different names for the same ruthless force of nature. The only real difference is their location. In the Atlantic Ocean, they're called hurricanes. In the Indian, they're called cyclones. And in the Pacific Ocean, they're referred to as typhoons. When strong clusters of thunderstorms drift over warm ocean waters, the warm air from the sea begins to rise, creating low-pressure areas on the surface of the ocean. Air rises faster to fill this low-pressure area, and combined with trade winds spinning in different directions, the storm forms. The balmy climate of tropical regions makes them perfect incubators for these storms. Hurricanes, cyclones and typhoons are placed on a scale based on their sustained wind speed. Storms become a level 1 hurricane or cyclone when winds hit 119 kilometres an hour. On land, that means damage to homes and power lines. Level 5 cyclones, with winds measuring more than 252 kilometres an hour, can cause devastating damage if they maintain that force at landfall, like Cyclone Yassi did in Queensland. At almost 1,500 kilometres wide, the storm didn't completely disperse until it had nearly reached Alice Springs, causing $3.6 billion damage. Extraordinarily, no one was killed. The story could have been so different without the early warning systems, shelters, and emergency response personnel. Storms don't even need to be at a Category 5 to cause that damage. When Hurricane Katrina hit New Orleans, it had already weakened, but still gutted the city. Unfortunately, floods are one of the most common natural disasters, but they are also some of the most destructive and deadly. It only takes 15 centimetres of water to knock a human down, and just 60 centimetres can move a car. Floods occur when excess water has nowhere to go. They are worse when the area doesn't have proper drains, but even advanced stormwater systems can be overwhelmed by a lot of rain in a short amount of time. Regions that are recovering from drought are even less able to cope with massive rains, even though it's just what they need. The ground is too dry to absorb the water. While floods can damage buildings and roads, cause blackouts and destroy crops, one of the biggest dangers they pose is the spread of disease. Not only can floodwaters disrupt water supplies, but none of the megalitres can be drunk. Dirty water and a lack of sanitation can lead to the rapid spread of influenza, gastro or meningitis, as well as potentially fatal outbreaks of cholera and dysentery. Large pools of stagnant water are also the perfect breeding ground for mosquitoes, which pose yet another health threat. Floods rarely get attention, but the waters can bring disease and great loss with them.